Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
I continue. Okay. So at the cathode here, we shall have sodium. We shall also have H plus. So we have competition between the chloride ions and the OH ions. Then competition between the sodium and the hydrogen ion. So this competition this time here, because of the increase in concentration, will be won by the chloride ions. That is if we have our electrodes as the carbon electrodes. So here at the anode we shall have chloride giving us chlorine plus 2 electrons, so we have chlorine gas. Then here again, actually here the factor of concentration is because of higher concentration of chloride we produce chlorine. But here, despite the fact that we have high concentration of sodium, again hydrogen will be discharged. So we shall have hydrogen. Should note that the hydrogen again is what? Is obtained. So we can put those physical states. So I can continue talking about this. You observe that when we have the graphite, that is our electrodes. So as we said, we have many factors affecting discharge. So when you have graphite, like for example, if you look at your screen, if you have the carbon electrodes, you'll observe that we have actually hydrogen and what? And chlorine. Hydrogen and what? Chlorine. So we can comment about the pH. Of our solution. So you observe this time we are removing chlorine and we are removing also what? Hydrogen. So what shall we remain with? We are going to remain with sodium hydroxide. And we shall say that the pH, and so the pH of the solution, the pH of the remaining solution, increases to what? Increase. Why? So the reason is because we are remaining with sodium, and this sodium will combine with the OH to give you sodium what? Hydroxide. And sodium hydroxide is a base. It is a base. So because it is a base, you'll observe that the pH will increase. And you know that pH of bases, if it is sodium hydroxide, it is almost 14. It is almost what? 14. So, as we continue with our discussion, I know you are following and it's somehow exciting. We can continue and talk about, again, the electrolysis of concentrated sodium chloride, because in the industrial manufacture, it helps us to manufacture chlorine gas. Chlorine is very important in our daily lives. Very important, like it helps in the manufacture of jig and other things. Then we have also production of hydrogen on large scale manufacture of hydrogen gas. So hydrogen is very important. It's very, very what? Important, as you know, from your senior 1 and 2 chemistry. Then sodium hydroxide, very, very what? Important. Especially, for example, in the manufacture of soap, we use it in the lab. So this electrolysis is very important in both, or in 3 ways. Production of chlorine gas, production of hydrogen gas, and even what remains is very important. So we can also use it in production of sodium hydroxide. So I was briefly telling you about our electrodes. You know, electrodes, the type of electrode will determine what we have at the anode and at the what? At the cathode. So again, we can consider again this electrolysis, and we try to dig deep when you have different types of what? Electrodes, especially those ones which are normally applied industrially. So you observe that industrially, when you use the carbon electrodes, these are our products. But if we change and we use, for example, if you look at your screen, we use, for example, the diaphragm cell. The diaphragm what? Cell. If you use the diaphragm cell, you observe again we are going to produce the same thing. But again, we have changed our electrodes. But again, we shall produce chlorine, hydrogen, and sodium what? Hydroxide. Sodium hydroxide. But if we change our electrode and we use the mercury, or we can say sodium mercury, the mercury cell, the mercury what? So as you see, you can see very well if you can look at your screen. You'll observe that we have the carbon electrode, which is our anode, and the mercury, which is acting as our cathode. So in this type of cell, despite the fact that it's not used very much these days, we shall produce sodium. We shall produce what? Sodium. Again, we say that if it was mercury, here, instead of producing hydrogen, and we have changed our electrode to mercury, we shall produce sodium. We shall produce sodium. So these factors sometimes come in. They come in and they affect what we have at the anode and at the cathode. At the cathode. So we continue. So the last part, we actually going to talk about when we have molten sodium chloride. Molten sodium what? Chloride. Molten means we have only sodium and the chloride ion. So here it means that at the anode we shall have only the chloride ion. And at the cathode we shall have only the sodium. So there is no competition. So if you have only chlorine, it means here we are going to produce chlorine gas with oxidation at the anode. And here we are going to have sodium, which is what? Reduction. Yeah, so here is somehow simple, not very complicated. So this application is applied in the industrial manufacture of sodium. But again, we can also have chlorine produced. So it is here, if you look at your screen very well, you'll observe that you can see where we have the down cell. Down what? Cell. Here you'll see, actually down cell we have the graphite anode, which produces chlorine gas. And we have our ion screen, or we call it the cylindrical steel, which is the cathode. Which is the what? The cathode. So meaning that if you consider the down cell, you observe that the anode is made out of graphite, or we can say carbon. And this one is made out of steel. Made out of what? Steel. So we're going to continue, that is briefly. So we have finished discussing about electrolysis of sodium chloride. So sodium chloride, we have talked about electrolysis of dilute. We have talked about electrolysis of concentrated. And when we have only molten, the simplest term is molten. It's because we produce only two things, which there's no competition. There's no what? Competition. But actually in the industrial scale, you observe that the one which is molten is one which is more complicated, because it requires a lot of heat to change it from solid to liquid, and also obtaining pure substance is also somehow complicated, making the process more complicated in terms of production. But in terms of understanding, it is simple. So again, we are going to look at another example where we have industrial manufacture of aluminium, extraction of aluminium from our bauxite ore. So we have very many processes, but the last process is actually purification, where we have electrolysis of molten sodium chloride. I think you can look at our diagram there. This time we use actually electrodes of carbon. Use electrodes of what? Carbon. Yeah. So we have the carbon anode and the carbon what? Cathode. Actually, this is graphite, and also placed in the steel what? Container. So we can briefly talk about it, and we say here, supposing we have electrolysis, let me illustrate it for you in very few minutes. Very few. So electrolysis of, you can say electrolysis of, you can say electrolysis of aluminium 3 oxide. So iron is present at 2, so meaning at the anode, at the what? The positive one, we shall have the oxide ion. At the what? Cathode, we are going to have aluminium 3 plus. Aluminium 3 plus. So here, if you want to produce oxygen, you just put an arrow and you put what? Oxygen. So you balance by putting a 2 here, it will become 4. Then you say 4 electrons. Then here, because there are 3, we put 3 electrons to get our aluminium. Actually, aluminium is produced in liquid state and oxygen is produced in gaseous what? States. So because this oxygen here, sometimes, not even sometimes, will react with the carbon anode, so to produce carbon dioxide. So it will always require you to replace the carbon anodes every time. So aluminium is in liquid form and it will be tapped off. It will be what? Tapped off in liquid what? Form. So that is simple about electrolysis of aluminium 3 chloride. Then we are going to look at, as we look at this electrolysis of different electrolytes, we can also look at another application, which is actually electroplating. Electroplating. So electroplating of different compounds. If you want to electroplate your metal with gold, or you want to electroplate it with silver, or you want to electroplate it with copper, you know these elements which are below hydrogen. This is very easy. It's very, very what? Easy. So you'll observe that here we actually talk about the electrolysis. Electrolysis of silver nitrate. Of silver what? Nitrate. So during this electrolysis, you recognize you've already talked about how we find the ions. If it is aqueous, we have silver, we have the nitrate, and we have H plus and OH. Then when we talk about the anode, at the anode we shall have is the positive. What shall we have? We shall have this one and what? And the OH. At the cathode, we shall have silver and what? H plus. So basically we concentrate so much, if it is electroplating, we concentrate so much on the cathode. On the what? On the cathode. This is because if you want to electroplate something with silver, like for example a metal ring, or we can say a ring they normally wear during the marriage ceremonies. Or this time in our example we have a spoon. If you want to electroplate your spoon with what? With silver, you make sure you put it at the cathode. Why? Because at the cathode is normally where we deposit, for example, silver. We deposit what? Silver. So how do we deposit silver? You see how we deposit silver. So we have competition here. And the competition will lead, because H is lower in the electrochemical series, it will be the one which will react. It will be the one which will what? React. Then this is where my basis of emphasis, silver. So here there is competition between silver and hydrogen, but silver is lower in the electrochemical series. So we shall have here silver plus an electron, and silver will be deposited. It will be what? deposited. If it is a spoon like you see on your screen, is actually the spoon will be covered with silver what? With silver metal. So comment about the pH. So because we remove actually silver and OH, so the pH will reduce because we shall remain with H plus in the what? In the solution. I'm going to leave you with an exercise. Hope you've understood what we have been talking about. If you have any question, you can ask. So here is an exercise for you. You try it out, very simple. If you followed what we have discussed, our exercise is very, very what? Simple. It's saying, the first question says, with the help of equations of reaction which occur at each electrode, outline what happens during the electrolysis of aqueous sodium what? Chloride. So then the second part is telling you what happens to the pH of solution as electrolysis what? Continues. We have discussed that, and I know you're going to do it very well. So you make sure you write the equation at the anode, at the cathode. If there is what is remaining, you talk about it. Then again, number 2, using a diagram, you draw the diagram and the equations, explain the process of electrolysis of aluminium 3 oxide during the manufacture of aluminium from what? Bauxite. This is the last process. So I know you're going to do those things. So thank you very much for following. Thank you very much for following. And I know we are going to meet next time. God bless you very much. tujye gufekenya. I don't know if I'm the one with the problem always. When I mix my stomach with very many things.